Hello everyone. Today we are going to talk about converting decimal numbers to binary using the subtraction method. As you can look at the top left of the board, I have written 2 to power 4 on the left, 2 to power 3, 2 to power 2, 2 to power 1, 2 to power 0, and just below that we see that 2 to power 0 is equals to 1 as we know it. 2 to power 1 is equals to 2, 2 to power 2 is equals to 4, 2 to power 3, 8, 2 to power 4 is equals to 16. And as we know, the relationship using the decimal number system on the place value, you know that in order for you to move to the left, these numbers on the left are 10 times greater than the ones on the right. So with these ones, the number on the left is always 2 times bigger than the one on the right. And this is just the continuation. Remember, you did the conversion using the manual method. Now we want to know how much, for example, will 20 be as a binary. So on the right, top right, we have the table whereby I've written out the powers of 2 and their equivalent numbers in decimal. This time around, remember on the decimal, you had the units, which is the ones column, and then you had the tens column, the hundreds column, thousands column, all the way. Now we are talking of the powers of 2. So it's about the ones column, the twos column, fours column, eights column, 16s columns, all the way. Now, when we use the subtraction method, you first look at the number and try to check which number the highest power of 2 that can be subtracted. So when we look at 20, from the table, the highest power of 2 that can be subtracted is 16. Then when you subtract 16 from 4, you get 4. And from 4, the highest power of 2 that can be subtracted is 4. And then you get 0. So when we get the 0, then that's where we stop. So looking at the table on the right, top right, A for number 20, you see that under 16 I wrote 1 and under 4 I wrote 1, simply because 16 was subtracted and 4 was subtracted. Those were the only two highest powers of 2 which were subtracted. Elsewhere you put a 0 because it's about whether that was subtracted or not. So when you look at it, 23, how much will it be as a binary? So the calculations follow. 23, the only highest power of 2 that can be subtracted there is 16. Subtracting that, you get a 7. From 7, the highest power of 2 that can be subtracted is 4. You get a 3. From 3, when you subtract a 2, which is the highest power this time around possible, you get 1. And from 1, the only highest power of 2 that can be subtracted is 1, and you get a 0. So once you get a 0, that's where you stop. So going back to the table, for number 23, under 16 I wrote 1 because 16 was subtracted. Under 4 I also wrote 1 because 4 was subtracted. Under 2 I have written 1 as well because it was subtracted. And I lastly wrote 1 because it was subtracted. 1 under 1, which is 2 to power 0. So for 2 to power 3, which is the eighth column, I wrote 0 because 8 was never subtracted. And then when we go to number C, which is 27, we want to know how much that will be as a power of, in fact, as a binary number. Now the calculations are as follows. 27, the only highest power of 2 that can be subtracted is 16. And then you get 11. From 11, the highest power that can be subtracted is 8. You get 3. From 3, the highest power that you can subtract is 2. You get 1. And from 1, the highest power of 2 that can be subtracted is 1 because it's 2 to power 0. Then you get a 0. So once you get a 0, you stop. So When you go back to the table, under 16 I wrote 1, under 8 1 because they were subtracted, under 4 0 because 4 was never subtracted, under 2 I've written 1, and under 1 I've written 1 as well. That's how it goes about. And remember, when you write them, it has to be clear that it is 20 base 10 is equals to 10100 base 2. Thank you very much for watching. Let us watch out for the next video.